Hello, this is Mr. Zamoyski from North Tonawanda High School, and this is the second quarter lab titled Separation Techniques. In class, we've looked at separations of mixtures, and mixtures are substances that contain two or more components that are not chemically combined. And so you can take them away from each other or separate them by taking advantage of the physical properties of the components of the mixture, which are retained, unlike in a chemical reaction where the physical properties of the substance may change after the chemical reaction has occurred. Before we talk about exploiting physical properties to separate components of a mixture, let's first talk about what a physical property is. Physical property tells you about the substance, and it's an identifier of the substance. This includes things such as density, or how much stuff there is in a given amount of space of that substance, melting point, at what temperature it goes from a solid to a liquid, and boiling point, at what temperature it goes from a liquid to a gas. Solubility is also a physical property, or how well that substance dissolves in another substance, typically how well it dissolves in water. You can use physical properties to identify or tell the difference between two substances. For example, in our density of plastics lab, certain substances sink or float based on their density. The physical properties of a substance don't change unless the substance undergoes a chemical reaction and changes its identity. A physical change is a change in something about the substance that doesn't change its fundamental identity. It still has its essence or the same makeup. For example, we've been doing some labs with ice, and this ice will melt eventually if I leave it out, but it's still the same stuff. It's still molecules of H2O. So if I collect that melted ice or water and put it back in the freezer, it'll turn back into ice. So it's still essentially the same thing. Another common example of a physical change is just using deformation. I have a sheet of paper. I crumple it up, and it's still paper. I can smooth it out, still write on it. It's still fundamentally paper. Even when you dissolve things too, for example, I have salt and water here. Okay. It may look like the salt disappears, but there's still fundamentally salt and still fundamentally water. I could taste it if I were to drink this and note that the water tastes different with the salt in it than it does without the water. And if I were to leave that out for a while, eventually all the water would evaporate and have salt left over. Here's a chemical where we have an example of a solid and a mixture. So this is a mixture of copper to chloride, and if I left this out for a long time, it would turn into this powder of a very similar color. For a mixture, you can take advantage of any of the physical properties of that substance to separate it. For example, you could use density, which we did in our density of plastics lab. You could use solubility, or you could use temperature of a phase change, such as a melting and a boiling point. For today's lab, what we're going to do is we're going to look at differences in solubility and differences in particle size and differences in boiling point to separate components of our mixture. So let's begin the lab. For this lab, the chemicals you'll be working with are a white powder known as sodium sulfate. Sodium sulfate looks a lot like common table salt or sodium chloride. However, there is a skin hazard associated with it, and you'll see that in your SDS for sodium sulfate. So what you're going to do when you're handling sodium sulfate is you're going to put disposable gloves on. You'll see in the SDS for sodium sulfate solution, which is what you're eventually making, that it becomes non-hazardous when it's dissolved in water. So just the solid powder form is hazardous. But for that brief time that you're going to use the solid powder, you're going to have disposable gloves on. You're also going to be working with a solution of calcium chloride. You'll see there's no hazard associated with that. But since we are working with chemicals and glassware and eventually we'll be using heat, we will, as always, be wearing our goggles. And then what you'll do is you'll get a test tube and a wooden test tube rack. You're going to take your metal scoop and add 1 scoop of sodium sulfate to to the test tube. And you close that up. Your next step is you're going to measure 10 milliliters of water using a graduated cylinder. And I overshot my 10 milliliters there. So I'm going to use a plastic pipette to help lower my volume until I get exactly 10 milliliters. Remember that you're looking for the bottom of the curved line. That's our meniscus, and that tells us the exact amount of volume we have in the graduated cylinder. Next, what you'll do is you'll carefully transfer the water to the test tube. And now you have a mixture of water and sodium sulfate. You're no longer working with solid sodium sulfate, so you can take your gloves off at this point. We have a mixture of sodium sulfate and water, but as you can see, there's a small amount of white powder sitting at the bottom and not dissolved. In chemistry, there's two ways we can make things dissolve. We can either shake it or stir it, but that's not always the best option. What you can also do is raise the temperature of the mixture, and that will make the powder dissolve much more quickly in the water. To do that, we're going to use our Bunsen burner, and at this point, you're going to tie any long hair if you have it back, and if you have any loose articles of clothing, you're going to secure those, or if it's like a hoodie or something like that, you can take it off. You're going to check and make sure that the gas line underneath your station, that yellow lever, is pointed to the side and not straight down. And also check with your instruction to make sure that the main gas line is turned on as well. You're going to light your Bunsen burner using the standard procedure where you're going to start your fire first before you turn the gas on. And you're also going to make sure that the bottom of your Bunsen burner is unscrewed a little bit so that the gas can come from the laboratory station gas line into your Bunsen burner. So I'm going to do my lighting procedure, and also I'm going to secure my tie as well. So go ahead and light your fire, and then get your Bunsen burner to turn on. You want your flame to be only a couple inches high, so if it's super tall, you're going to go ahead and turn the knob underneath it counterclockwise until you get about a 2-inch flame. Also, if you have an orange flame, that's not what we want for this lab. So you're going to go ahead and unscrew your barrel counterclockwise until you get that double blue on blue flame, with the lighter blue flame on the inside and the darker blue flame on the outside. When you're heating liquids in the lab, it's important that you have the opening of the container pointed away from you on the chance that it might splash, and you want it not to go into your face or onto your clothes. Also, when you're heating things, you want to make sure that you're far enough away from the thing that you're heating. So I'm going to use these little test tube holders, and I'm going to hold it at the end, and I'm going to put the bottom of my test tube into the hottest part of the flame, which is at the top of the inner blue cone, and we're going to keep it in there until the sodium sulfate has completely dissolved. Make sure you're securely holding your test tube holder, because when this starts to boil, it does jump around a little bit. Now that my sodium sulfate is completely dissolved, it took less than a minute. What I'm going to do is I'm going to turn off my gas line to my Bunsen burner. We will need that later. We will need the Bunsen burner later, but right now, while we're doing other stuff, we're going to have it off. And what you'll do is you'll take your test tube rack and put the test tube in there, and then release the test tube holder. For this next part of this lab, we're going to do a chemical change to the mixture of the sodium sulfate and water. What you'll do is you'll take your test tube of sodium sulfate and water, and you're going to get a sample of calcium chloride.
Hello.
Hi, how you doing?
Oh, just peachy.
And you're going to take your plastic pipette and add a small amount to the mixture, and some sort of change should be very apparent. And we'll set that aside for a moment and let the change finish out. For the next part, you're going to do your first of two separation processes. Separation process is anything that takes advantage of different physical properties of the components of the mixture. And the first one we're going to do is called a filtration. If you're a coffee or a tea drinker, you've already taken advantage of this separation process. For tea, you have the tea ground up inside the tea bag, and you pour hot water, and the hot water will dissolve some of the materials in the tea bag, and it'll pass through the tea bag, while most of the material remains inside the tea bag because the particles are too large. Same thing with your making coffee. You'll have your coffee grounds, you put it in a coffee filter, pass hot water through it. The hot water will dissolve some of the material from the coffee, while the big coffee grounds stay behind. To do this, what you're going to do is you're going to get a metal stand with a small iron ring attached to it. And the only reason for this is that the filtration process can take a long time. So rather than having you hold the materials, you'll have this do the holding for you. You're going to take an evaporating dish. Either it's made of glass or it's made of white porcelain. I'm going to put that underneath. And then what you'll do is you're going to get a funnel and then a coffee filter. And you're going to put the coffee filter into the funnel and sort of wrap it around the outside so it sits nicely on its own. And then what you'll do is you'll take your test tube of your mixture and pour it into the coffee filter. If you have a little bit of white solid left over in the test tube, that's fine. You're going to sit back and wait until all of the liquid passes through the coffee filter, and you should have a white powdery solid remaining in the coffee filter. My filtration is complete, and so I'm going to take my coffee filter with the white substance left over on it, and I can simply throw it away in the trash. When we did the chemical change a few steps ago, you reacted a mixture of calcium chloride with a mixture of sodium sulfate. And one of the products you made was a substance called calcium sulfate, which is what limestone is made of. And then you made another product as well called sodium chloride. Calcium sulfate doesn't really dissolve in water, and so we were able to catch it in the filter. Sodium chloride, which is also known as table salt, does dissolve in water. And so in order to recover the sodium chloride that we created from our chemical change, we're going to need to do another separation process called a distillation. While a filtration takes advantage of particle size to separate a mixture, distillation takes advantage of the difference in boiling points between two substances. Normally for a distillation apparatus, you'll collect the liquid that you're boiling off, but in this case, we don't need to do that. We're going to take advantage of the differences in boiling points between the water and the sodium chloride. To do your distillation, what you'll do is you'll take your funnel off of your filter setup, and you're going to unscrew your iron ring so that you can raise it up a little bit higher. And you're going to take your evaporating dish of colorless liquid and put it on top. And we're going to go back to using our Bunsen burner. Okay. So I'm going to set this aside for a moment here. You'll go ahead and go back to lighting your Bunsen burner. Remember, always fire first. And then what you can do is, if you need to, you can raise up your flame height. And what you'll do is you'll sit back and wait until the water completely boils and see if you have anything left over. As you get towards the end of your boiling, some of the material may splatter, so just make sure that you're a safe distance away. Once the water is mostly dissolved, what you'll do is you'll turn off the gas. and you should have something left over in your evaporating dish. You're going to carefully transfer it from the heating station using a set of tongs onto a wire mesh until it cools. After that, leave aside all the hot materials to cool down and perform your cleanup. There's no post-lab or any other activities you have to do afterwards. This is the end of the video for the second quarter lab separation techniques. Before you come to lab, make sure that you've completed the pre-lab assignment, answered all the questions, read over all the SDS for this lab, read over the procedure, and you've made sure that you're properly dressed to do this lab. Have a great day.